Okay, so today we're doing section 3.6. We're going to be solving inequalities, and there will be one-step inequalities, and then we will graph the solution to that inequality on a number line. So you will see as we go through this, solving inequalities is very much like solving an equation. There's going to be one little difference. But first, let's talk about what an inequality actually is. So an inequality compared to an equation. When we've been working with equations, we have an actual equal sign. And when we're given a word problem, or that word is, tells us is equals. So we can translate the actual word into a math symbol is the equal sign. Well, with inequalities, we have a verb. It's a mathematical sentence with one of the verbs being, and then we have these symbols. Right here we have the less than symbol and the greater than symbol. So in words, this means less than. This means greater than. I know sometimes we have trouble remembering which one is less than and which one is greater than. So one thing I like to think of, less than starts with an L. So I take an L and I kind of tilt it on its side, and that's going to be my less than symbol. So in addition to less than and greater than, we have less than or equal to and greater than or equal to. So notice it's the less than symbol with a bar. So this is just less than or equal to. And this other one is greater than or equal to. And we'll talk about what that means more here in a little bit. So basically an inequality is going to be something that's greater than or less than, not exact. Whereas an equation, we're talking about an exact equals only. So, with an inequality, we have an infinite number of solutions. Whereas with an equation, we have exactly one. There's only one value that we can substitute in and make the equation true, so the left side equals the right side. Whereas with an inequality, we're going to have an infinite amount of numbers and what's actually called a solution set. So with an equation, we have one actual solution. With an inequality, we have what's called a solution set. So for example, x equals 2 means x can only be 2. That's the only value that's going to make the equation true. So the only solution is x equals 2. Whereas if we have the inequality x is greater than 2, this means x can be any value it wants as long as it is greater than 2. It could be 2.000001. It could be 2.2, 2.3. It could be 15,000. So it has an infinite number of solutions. It can be any number as long as it's greater than 2, anything thereafter. So every decimal, every fraction, every whole number, every integer after 2. So while we say x is greater than 2, this means x can be any value, any real number greater than 2. So let's look at that. So I verbally gave you some examples, but let's actually look. Okay, what's going to satisfy this inequality? What's going to make the inequality true? So some examples that would make the inequality true for x is greater than 2. We could say 2.01, 2.00001. So very close to 2, but not exactly 2. 2.2, 10, 18, 19.3, 5 halves. Ooh, that one's close to 2.5. But so these are all examples that make the inequality true. Now these aren't the only examples, but they're just some of them because we have an infinite number of solutions that will satisfy x is greater than 2. We can also represent this using set builder notation. So if you recall, we start with a bracket and we put x such that, so don't forget that's what the colon means, x is greater than 2. So this just means x such that x can be any number greater than 2, bigger than 2. So when we have a solution set, we have what is called a boundary point. So within inequalities, we have a boundary point. That's the number that separates the values that make the inequality true from those that do not. So basically, if x is greater than 2, 2 is my boundary point because now I'm saying everything to the right of 2 will make the inequality true, whereas everything to the left of 2 makes it false or does not make the inequality true. You will also see what we call as double inequalities, also known as compound inequalities, and these are especially true when we are dealing with word problems and real life problems, which we'll look at more tomorrow. But this will create, these double inequalities will create an interval of solutions between two numbers known as the endpoints. So basically, with a double inequality or a compound inequality, we have two boundary points. So two values that mark these are solutions. Anything from here on is a solution, but then this way is not a solution. You'll see more of what that means when we get into a number line though. So for example, let's say we have this compound inequality, and we can read that as -5 is less than or equal to x, which is less than or equal to 8. And sometimes what I like to do is to split these up. So this is the same thing as saying x is greater than or equal to -5. So basically if I act like this part isn't here, notice though my inequality is still facing the same direction. So sometimes it helps to switch it up instead of seeing it as a compound. Compound is meaning more than one. So x is greater than or equal to -5, and then also x is less than or equal to 8. So if you want to split that up, separate it, that's fine. But notice, keep in mind they do go together. It's representing a certain solution set. This means x can be any value between -5 and 8. So x is less than or equal to 8, but greater than or equal to -5. It could also actually be -5 or 8 because we have this equal to. So the equal to means it could actually be that value, that solution, that number is included in the solution. So if we look at this on a number line, and one thing you'll always want to do for me is mark where 0 is. And then also, I always want to know what you're counting by because we won't always count by ones. In this case, I am just because they're nice small numbers. Now, you don't have to mark every single value because as soon as you mark a couple of them, I'll know what you're counting by. So, x is less than or equal to 8. I'm going to put a closed circle there, less than or equal to, so everything's smaller than 8, so I want to shade everything to the left. X is greater than or equal to -5. So I put a closed circle at -5, greater than or equal to, bigger than, so everything to the right. So this solution set, and the way we show it with a number line, I've got my two endpoints, my boundary points, showing that, hey, everything between -5 and 8 is a solution. So any number I wanted to choose between these two values would be a solution to the inequality. So for example, if I choose 1, is 1 less than or equal to 8? Yes. Is it greater than or equal to -5? Yes. Now if I choose -6, -6 is less than or equal to 8, true, but it is not greater than or equal to -5. So that's just how we can represent a solution set on a number line, which we will be doing. So you heard me talk about the closed circles at -5 and 8. So the closed circle represents greater than or equal to and less than or equal to. An open circle represents greater than or less than. So closed circle, it's always greater than or equal to, which means that value is included in the solution. Greater than or less than is an open circle, so that value is not included. It's everything as close as it can be to that number, but it will never be exactly that number. So let's look at a list of numbers in order from least to greatest. -10, -5, 0, 1, and 30. So let's use an inequality to show the relationship between these numbers. So they're already in order from least to greatest. So what I mean by showing this as a relationship using an inequality is just saying -10 is less than -5, which is less than 0, which is less than 1, which is less than 30. So -10 is less than -5, -5 is less than 0, 0 is less than 1, 1 is less than 30. Okay, so that's true. So now, what happens though if we multiply each of these numbers by a -2? Well, we get 20. -2 times -5 is 10. -2 times 0, -2 times 1, and -2 times 30. what happened to those values? Is this still in order from least to greatest? No. If you notice, everything switched, because now really what happened is I'm going in order from greatest to smallest, or from greatest to least. So let's look at these. Okay, so really what happened was this became 20 is greater than 10, which is greater than 0, which is greater than -2, which is greater than -60. So when we multiply each of these numbers by a negative number, what was the smallest is now the largest. So what was the smallest number, I multiplied it by a negative, so what was the smallest became the largest. If you think about it, the smaller a number, if I have a negative number and I multiply it by another negative number, it always becomes positive. But if it's -10 and I multiply it by a negative, because it was the biggest negative number, now it becomes the biggest positive number. So what happened to the inequality? It simply flipped. So we went from least to greatest, we multiplied each number by a negative, and then it flipped and went from greatest to least. That is especially important when it comes to solving these inequalities. So when that happens, when we multiply by a negative, and that sign flips, that's called changing the sense of the inequality. So when we multiply or divide by a negative, when solving the inequality, we must flip that inequality sign. The reason being, because of what we just did. We started least to greatest, multiplied each one by a negative number. All of a sudden, what was smallest became the biggest. So, other than that, solving these inequalities is exactly like solving an equation. 3x is less than 18. I want to get x by itself, which means I just want 1 times x. Well, what can I multiply or divide by to get x by itself? I can either multiply by 1/3, the reciprocal of 3. Any number multiplied by its reciprocal is 1. Or that's the same thing as saying divide by 3. So you end up with x is less than 6. That's my solution. So the exact same steps, it's just we don't have an equal sign, we have a less than sign. So what does that look like on a number line? Well, we have 0, 1, 2, 3, 4, 5, 6. It's going to be an open circle because it's not equal to. So here's 6, and it says less than. So I want to shade everything to the left. So I just shade it, and then I show an arrow to say, hey, everything forever to the left. Some people like to do this as well, which I'm fine with. That works. So what does that mean? That means 5.99999 could work, but 6 will not. Because if I plug in 6, I get 18 equals 18, not 18 is less than 18. So I can plug in -1, because that's part of my solution set. 3 times -1 is -3. Is that less than 18? Yes, so it makes that inequality true. So that's how you can always check your answers, is taking any number from that solution set and plugging it in to verify that it makes the inequality true. Just as we did with equations, we took that solution, plugged it in, make sure left side equals right side. Okay, 1/4 x is greater than 5. Well, how do I make the coefficient, the number in front of x1? Multiply it by its reciprocal. So the reciprocal of 1/4 is 4, or 4/1, however you want to write it. If I multiply the left by 4, still have to multiply the right by 4. So this becomes 1x is greater than 20. So my solution set is any number that is bigger than 20. So on a number line, I'm going to put 0 there, I'm going to count by 5s, 5, 10, 15, 20. But I want to make sure I know what I'm counting by. Again, it's another open circle because it's not equal to, so open circle means just greater than or less than. And because it says greater than, I want to circle everything, or I'm sorry, shade everything to the right. So that means x could be 20.1, excuse me. Whew, excuse me, 20.2, 20.3. It could be 32, so if I plug in 32, 32 times 1/4 is 8. Is 8 greater than 5? Yes. So any value to the right of 20 will make the inequality true. Okay, last couple here. We have -2 times m is less than 44. So how do I make this 1? Multiply it by its reciprocal, which is -1/2, which is the same thing as dividing by -2. So we get m is less than -22. Now be careful because we're multiplying or dividing, however you want to say it, by a negative number. So don't forget that sign must flip. If it doesn't, we do not get it right. So 44 divided by negative 2 is a negative 22. So my solution set is any number bigger than negative 22. So when I go to graph this, 0. I'm going to go ahead and count by 5s again, but I will mark. I'm going to say guesstimate where 22 is, or negative 22, and I'll mark it. So now I'm greater than, so everything to the right. So any number to the right, bigger than, greater than, the numbers get bigger as I go to the right, so I shade to the right. Very last one, negative 2/3 n is greater than or equal to 4. I need a coefficient to be 1. Any number multiplied by its reciprocal is always 1. So I multiply this by negative 3/2, which means I multiply the right by negative 3/2. Negative 6/6 is just 1. Again, I'm multiplying by a negative, so I got to flip that sign. This is the same thing as saying negative 12/2, which is the same thing as saying n is less than or equal to negative 6. So in this case, negative 6 is included in the solution. So the way I represent that on a number line is with a closed circle because it is equal to. Less than, so anything to the left of negative 6 will work, including negative 6, because it can be greater than that number or equal to as well. So that's solving one-step inequalities. Finish up your homework problems, read, and I will see you tomorrow.